Hello and welcome to the third session on the topic time, speed and distance. Santosh, a marathon runner, runs from his home towards his office, which is at a distance of 55 km at a speed of 40 km per hour. After running a certain distance, he increases his speed by 25%. And then he reaches his office in 1 hour 15 minutes after leaving his home. After what time did Santosh change its speed? This should be his speed. Now it is given that home to office distance is 55 kilometers. Santosh goes with a speed of 40 km per hour till some point, and then he increases his speed by 25%. 25% is 1 by 4. 1/4 of 40 km per hour is 10. So an increment of 10 km per hour. 25% increment or 10 km per hour increment. So the next speed is 50 km per hour. So the two speeds are 40 km per hour and 50 km per hour. Now the question is, after what time did Santosh change its speed? So let us assume that Santosh traveled for a time t in which his speed was 40 km per hour and afterwards his speed was 50 km per hour. So the total distance is given as 45 km. For the first few distance, time is t. So the remaining time will be 1 hour 15 minutes minus t hours. Right? 1 hour 15 minutes is nothing but 1 hour plus 15 minutes is 1/4 of an hour, quarter of an hour. So you can easily write 1 by 4 hour. This will be 5 by 4 hour. Okay. So he travels at 40 km per hour for time t, and he travels at speed 50 km per hour for a time 5 by 4 hour minus t. Okay, and this distance is given as 55 km. We have done nothing but speed into time for the entire journey. So you see 10t will be equal to 250 by 4 minus 55. Let's see what do we get t as. This is 62.5 minus 55. So this will be 7.5. T will be 7.5 by 10. This is in hours. Okay, so we convert this as minutes. We multiply by 60. 7.5 into 6. 7.5 into 2 is 3. Sorry, 7.5 into 2 will be 15. 15 into 3 will be 45. So 45 minutes. So option D should be the answer. Let us see the next question. A train leaves Hogsmeade at 40 km per hour. At the same time, another train departs from Diagon Alley at a speed of 60 km per hour. They reach the respective destinations and turn back immediately towards the starting points. Now, if they meet at a distance of 200 km from this is not A, this is Hogsmeade. From Hogsmeade, what is the distance between Hogsmeade and Diagon Alley? Let us draw this. Hogsmeade to Diagon Alley. First train starts from Hogsmeade it reaches diagonally and then comes back. Similarly, the train that starts from diagonally reaches Hogsmeade and then comes back. So this is their second meeting point, and this meeting point is 200 km away from Hogsmeade. If you think about the train that starts from Hogsmeade and goes to diagonally and back, it covers a distance equal to this distance L, plus it comes back from diagonally till this point. So if this length is 200, this is L minus 200. So the total distance covered by this train is 2L minus 200. Similarly, the other train that starts from diagonally to Hogsmeade, it covers the entire distance L once, and then it turns back and covers 200 km from Hogsmeade and meets the other train. So these are the two distances covered. Now the time to cover this distance is same for both the trains because they are meeting at a point. That's why if you think about the ratio d by s is constant, the time is constant, right? So distance ratio will be same as speed ratio. Essentially, if the time is constant, speed ratio will be same as the distance ratio. What is the distance ratio? 2L minus 200 L plus 200. And what is the speed ratio? 40 km per hour is the speed of this train and 60 km per hour is the speed of this train. What is the ratio? 2:3. If you solve it, this will give you 6L minus 600, 2L plus 400. You'll get 4L equal to 1000 and L equal to 250. So your answer should be 250 km. I hope you understood the logic. This is simple. They meet for the second time. Okay. The train that starts from Hogsmeade reaches diagonally and comes back. And the train that starts from diagonally reaches till Hogsmeade and then comes back. And this meeting point is 200 km away from Hogsmeade. So the time is same because they meet at a point. Since the time is same, speed ratio will be equal to distance ratio, and distance we can calculate as 2L minus 200 by and L plus 200 for the second train. Solving the equation, we will get 250 km as the distance between Hogsmeade and diagonally. Hope you understood this. Let us attempt the next question. Amit and Ravi start from JMT and HWH respectively towards each other with the speeds of 20 km per hour and 49 km per hour. After they cross each other, Ravi covers another 145 km to reach JMT. What is the distance between JMT and HWH? Let us draw a figure. This is JMT and this is HWH. Amit starts from here and Ravi starts from here. They meet each other, cross each other at a certain point. Okay, and then it is given that Ravi has to cover another 145 km to reach JMT. So this distance is given as 145 km. Okay, what is the distance between JMT and Howrah? What else do we need? The speed is given as 25 km per hour and this is 49 km per hour. See, if the speed is 49 km per hour and the distance is 145, you know how much time does Ravi take to move from this meeting point M till his destination, which is JMT. Okay, Ravi takes how much? Ravi takes time to cover MJ is equal to distance divided by speed. Okay, let this time be something T1 or T2. You can take this to be T1. Okay, what is the speed? Speed will be 49. His speed is 49 km. Similarly, when Amit starts from JMT towards HWH, okay, he crosses this point M. Okay, what is the time taken by Amit? Amit takes time to cover JM. Okay, let this time be T2. This time is not given, right? This time is not known. T2 is unknown. Okay, as you realize from the expression S into T is equal to distance, because there is no second formula but only this one. Since the distance is constant, 145 km is constant, product of speed and time will be constant, which also means that speed is inversely proportional to time. So if you write S1 by S2 equal to, you should write T2 by T1. Okay, S1 is Ravi's speed, which we have taken here. This is 49. What is S2? S2 is 25 given Amit's speed. What is T2? T2 we have to calculate, so we put T2 here. And T1 we have assumed this to be 145 by 49. 145 divided by 49. So this 49 will get cancelled because 49 will come up here in the numerator. And T2 will get as 145 by 25. So we got the time T2. Okay. Now T2 is the time that Amit takes to cover this distance, right? Okay, and this is the meeting point. You know that this is the meeting point when both of them travel towards each other. Amit also starts from here and Ravi also starts from here. So in the same time T2, Ravi would have covered H to M, right? This is the meeting point. Ravi would have covered HM in the same time. So what is the total distance? The total distance will be speed into time. This will be speed of Amit, 25 into time, this time, or you can write relative speed will be total 25 plus 49. And what is the time? Time taken is 145 by 25. Okay, what is the value? This will be 74 into 145 by 25. Let us reduce this. 5552 29 by 5. This will be approximately 74 into 6 or something lesser than 74 into 6. 74 into 6, 6742. Okay, so close to something which is lesser than 444, but there is no option which is closer to 444 and less than that, so we'll go for the option D. I hope you understood the method and the approximation at the last, and please stay tuned for the upcoming sessions. Thank you.